Short-term climatic patterns. So the seasons. Seasons are short-term periods with specific weather conditions caused by regular variations in daylight, temperature, and weather patterns. Seasonal variations result from changes in the amount of solar radiation. Now, solar radiation varies due to Earth's tilt on its axis. So Earth is tilted on its axis at 23.5 degrees. But in the summer, the North Pole points toward the sun. So in the summer, we have the North Pole here. It is pointing towards the sun over here. In winter, the North Pole tilts away from the sun. So if we come around here 6 months later to winter, the tilt doesn't really change, but the position of the Earth does. So now the North Pole is tilted away from the sun. Now the South Pole tilts opposite that. So if we go to the summer for the South Pole, it's tilted away from the sun, and in the summer, the South Pole is tilted towards the sun. Now, during the spring and fall, neither pole points toward the sun. So if we looked at this, these aren't really pointing towards the sun. They're kind of in a plane. The plane of the sun would actually kind of come right around here as far as like where the sun hits the Earth, and those poles would be in line with that. So you kind of think about it this way. It's winter here right now, but then it's summer in the southern hemisphere. So if you went to South America, it would be summer right now. Now, just to show this again, Earth's tilt in the seasons. So if the sun is kind of over here somewhere, okay, then our sunlight is coming in this way. And in the northern hemisphere, this would be winter in the northern hemisphere because the North Pole is pointed away from the sun. This would be summer in the southern hemisphere. It's kind of what we have right now. It's kind of what's going on right now. In the summer here, when it's summer in the northern hemisphere, this would be kind of flipped. So the North Pole will be pointed this way. Of course, it really doesn't change. It's just the position of the Earth. The Earth kind of is revolving around the sun. During fall and spring, though, with the sunlight coming in like this, the North Pole is kind of pointed off in this direction, and this would be pointed off in that direction. So they're really kind of in line with this sort of horizon here that the sun is making on the Earth. So you have this sort of shadow line over here. You got sunlight over here, and the North and South Pole are kind of in line with that. So neither one of them are pointing towards the sun in the fall or the spring. Now, El Nino. So El Nino refers to a band of anomalously warm ocean temperatures that occasionally develops off the western coast of South America. Now we have some diagrams here in a minute. But normally, the trade winds, which are some fairly constant winds around the equator, but these trade winds and ocean currents, these equatorial currents, push warm water into the western Pacific. So normally they're pushing water to the west. Okay, so they're pushing water away. Now, normally, atmospheric and ocean currents transport cold water from Antarctica to the southeastern Pacific Ocean. So we get water from the Antarctic region. So we got cold water coming from Antarctica kind of up along the coast of South America, the southeastern part of the Pacific Ocean. Now, this is maintained by a semi-permanent high-pressure system, which a high-pressure system basically causes air to sink and kind of push out from that area. Now, this creates a cool, dry climate along much of the southwestern coast of South America. So South America, the western coast is generally cool and dry. Now, occasionally, this high-pressure system weakens and allows warm water from the western Pacific to surge eastward towards South America. So sometimes that system breaks down and you get this surge of warm water that comes back over to South America, and that causes an El Nino. Now, what this looks like as far as diagrams go, normally, again, we have these trade winds that kind of blow towards the equator, and you have these equatorial currents, okay? Now, these equatorial currents basically carry this warm water to the west, so into the western Pacific around Australia. So you get this warm water area here around Australia. And then we have this colder water come up from Antarctica along the coast of South America. That's normal. And again, there's this high pressure system here that's kind of pushing air down and away. Now, if that high pressure system breaks down and stops pushing this water away, well, you have this counter current that basically will start to push this warm water, all this warm water from the equator, back to the coast of South America here. And when that happens, basically now you have a lot of warm water right off the coast of South America, and that causes the climate to become warmer and wetter along the coast. And that's an El Nino. And again, our cold water current here is severely weakened. So the cold water current here coming from Antarctica, which is down here. Now, the effects of El Nino. So air temperature near the surface of the warm water increases, so the air temperature increases. And then convection current strengthens, so we have warmer air, and that warm air wants to rise. That basically creates stronger convection currents, and this causes the northwestern coast of South America to become warmer and wetter. And then this increased convection pumps large amounts of heat and moisture into the upper atmosphere. So we get a lot of heat and moisture in the upper atmosphere from this. And then this hot, moist air in the upper atmosphere can cause violent storms in other areas such as California or the Gulf Coast. So we basically have this warmer water, creates a lot of warm, damp air, which basically then ends up in the upper atmosphere, causing these violent storms. This could also cause drought conditions in other areas that are normally wet. So this is really just changing our weather patterns, completely kind of flipping them in certain areas. Now we have the opposite of that. We call it a La Nina. Now sometimes the trade winds blow stronger than normal. So remember, our trade winds are kind of blowing kind of south towards the equator or north towards the equator. Either way, they're moving towards the equator, but they blow stronger than normal. And what happens then is we push more and more of this warm water over into the Western Pacific. And then this basically causes the coast of South America to become colder than normal. So now we have this area where we've taken more warm water. And when that happens, you have more cold water coming up from Antarctica. So you end up with colder conditions along the coast of South America. You also end up with warmer and drier areas in the southwestern United States. So this can lead to drought conditions in the southwestern U.S. You also end up with more rain in Australia and Asia because you got all this warm water over here. That warm water causes water to evaporate. You end up with more humidity in the atmosphere. Warmer air can hold more moisture, so you end up with more rain. Now, the weather patterns here are exactly the opposite of an El Nino. Okay, so you kind of think about this. So it's the opposite of an El Nino. So if the coast of South America is colder than normal during a La Nina, it will be warmer than normal during an El Nino, etc. So you can take all these and kind of do the opposites, and you get the effect of an El Nino.